Alright, in this lesson we're going to start using matrices to solve systems of equations. And so here to review, we see a system of equations, and if we wanted to use elimination, we'd multiply this by -2 and we would get that. Then we could add and divide by 11, so now we found y. And then we can use y in equation B, put a 2 there, and now we've solved for x and y. And what happens with matrices, well, this doesn't use matrices yet, but we could start with the same system, and when we're looking at, we want to look at this first and make sure this is a 1x. So if we have a 1x here, I can just switch the equations. So I put this equation in as the first equation, and I put this down here. Now we have, instead of showing all the work, we're just going to write down what we're going to do, but we don't show the work. So this says multiply equation B by -2 and add it to equation A. And this is where it can be a little confusing because a lot is done mentally. So we're going to go -2 times that. Shoot. This should say -2 times A. This is an A, and that's a B. -2 times A. We're going to multiply this times -2 and then add it to that. But look what happens. We don't actually multiply by -2 and then rewrite it. We just keep copying it the same way it was originally. So I think that's where it can be confusing. We're going to go -2 times this plus that. So -2x plus 2x is 0, and that's why there's nothing left there, and we've eliminated that. Then we're going to go -2 times this is 8, plus 3 is 11, but we don't actually change this 4, we just keep copying it. And we also have to do -2 times this is 14, plus 8 is 22. So now we're at this stage. We have 1x and a 0, and now we want to make that a 1. So we're going to multiply by 1 over 11. This says multiply b by 1 over 11. So multiply by 1 over 11, we're going to get 1. Multiply by 1 over 11, we're going to get 2. This is row echelon form. And then we could do substitution with 2 there, and we'll solve for x. So here we have this is Gaussian elimination to get row echelon form. If we did one more step in this problem, which would be 4 times b plus a, 4 times b plus a is to eliminate that. And that would give us x equals, here we have y equals 2. We're going to go 4 times y plus -4y, and now it's gone. We're going to go 4 times 2 is 8, plus -7 is 1, and this is called reduced row echelon form. And just by doing that extra step, it has another name called and we're probably just going to stick with Gaussian elimination, because a lot of times when we start doing this, we're dealing with a lot of fractions going back to eliminate everything else. Okay, and before we get started, one more way of using notation. Instead of writing everything out, we would write it as just the coefficient, just the numbers and no variables. 2, 3, 8, 1, -4, -7. And this is called the, this is an augmented matrix. Augmented just means changed. So here we have the coefficient matrix combined with the solution matrix, and we write it as a changed matrix, an augmented matrix. We're going to be using this today, and just to prepare you for the next lesson, we could write this as a matrix equation. And we'll see how that, when we talk about multiplying matrices, you'll see why this works. But today we're just going to use that. So let's talk about how do we get things into row echelon form. Okay, if we have a row of zeros are at the bottom. The first entry has to be a 1, and the number below and left of each entry is 0. So let's try this. Alright, are these in row echelon form? So let's check. Row of zeros. Yeah, there's no row of zeros, so that's okay. First entry is a 1. Yes, the first entry is a 1. And then the number below and left of the first entry is 0. Below is 0. And now let's check this row. The first entry is a 1, and then we don't have anything below or left. So that is in row echelon form. And here we have the same situation, 1, 0, 1. As long as we have this 1, 0, 1 on both of them, it doesn't matter what else is over here. These are in row echelon form. So let's check this one. Alright, first entry is a 1. That works. But we also have this problem on number 1. row of zeros is at the bottom. So here we have a row of zeros, so that needs to move to the bottom. And then let's see what we have. So now let's check. The row of zeros is at the bottom. The first entry is a 1. The number below and left is a 0. First entry is a 1. The number below and left is a 0. The first entry is a 1. The number below and left is a 0. Alright, so that works. And you decide whether these are in row echelon form. So here we check, row of zeros is at the bottom. First entry is a 1, below it is a 0. First entry is a 1, below and left is a 0. Over here we see no rows of zeros, but the first entry is a 1, below is 0, first entry is 1, below is not 0. So this is in row echelon form. This is not in row echelon form. And we can't switch the order of these. We can switch a row with another row, but we can't switch columns. All right, and then one more strategy. I just made these numbers up. We're not going to solve it. I just want to show you the order in which we eliminate. So we are always going to start and make sure that's a 1. Then we'll use this to eliminate both of these. So that's the first step. Then we're going to make sure this is a 1 and use it to eliminate these. And then we'll make sure this is a 1. And that's for Gaussian elimination. So one more time. If it's not a 1, divide to make it a 1, and then use it to eliminate these. If this is not a 1, divide by its or multiply by its reciprocal to make it a 1, and eliminate and make a 0 there. We want to have a 1, 0, 0. Use this to make a 0, and then make that a 1. Alright, so we're going to write it as an augmented matrix. And yeah, if you make a mistake, you copy it wrong, the whole thing will be wrong, and so you want to be really careful with these. So we check. Is that a 1? No. We could divide by 3, this row, or we can just switch rows. So let's switch row 1 and row 3, and that means row 3 will now be here. And now we want to use this one to eliminate these, or turn these into zeros, and that's going to be row 1 plus row 2. We also can do -3 row 1 plus row 3. Alright, this is going to make a 0 there. -3 times that plus that is 0. And that will create the zeros. We won't actually change these numbers, we just copy them. So we're going to go row 1 plus row 2. Row 1 plus row 2 is 0. Row 1 plus row 2 is 3. Row 1 plus row 2 is -4. Row 1 plus row 2 is -33. And then we're going to have -3 times row 1. So that'll be a -3 plus 3. Then we're going to go -3 is -6 plus -1 is -7. We'll go -3 times -3 is 9 plus 2 is 11. -3 times -28 plus 3 gives us 87. So we did the first step, which was make sure it's a 1 and make zeros. Now we make that a 1, and then we're going to use it to make that a 0. So we have to multiply row 2 by 1/3. Alright, we made it a 1, and now we have to use it to make that a 0. So we have to multiply by 7 and add. So 7 row 2 plus row 3. Multiply by 7, and we're going to get so 7 times 0 plus 0. 7 times 1 plus -7. 7 times this plus that. That's going to be -28 over 3 plus 11. And we're going to end up with 5/3. And this is -77 plus 87 is 10. Alright, we want to make that a 1. So we just have to multiply by 3/5 on row 3, and then it will be in row echelon form. Three-fifths times 10 would be 6. And we read this as z equals 6. And then we're going to use this y minus 4/3 z equals -11. That's a z and a y, so we'll put the 6 there. And so we have z equals 6, y equals -3, and then we'll use that equation, which will give us x plus 2y minus 3z equals negative 28. X minus 6 minus 18 equals negative 28. X equals negative 4. So the solution is negative 4, negative 3, 6. Okay, and pause the video and try this problem. Just making sure they're all written down correctly. All right, go ahead. All right, we're looking, well, let's write it as a matrix, augmented matrix. 5, negative 5, negative 5, 35. Negative 1, 2, negative 3, negative 1, 2, negative 3, negative 12. 3, negative 2, 7, 30. And I'll double check, make sure I wrote it correctly so that we don't waste time. We need that to be a 1. And we could switch this row to the top, or we can just multiply by 1/5 because we're not going to get any fractions there. So 1/5 row 1. All right. And then we want to use that to make zeros here. So we can do row 1 plus row 2. And we can also do negative 3 row 1 plus row 3. We won't change row 1. But we are going to add 1 plus negative 1 is 0. Negative 1 plus 2 is 1. And adding these, we get negative 4. Adding these, negative 5. So negative 3 times that. Negative 3 is 3 plus negative 2 is 1. Negative 3 is 3 plus 7 is 10. Negative 21 plus 30 gives us 9. And then we want that to be a 1. Well, it's already a 1. And then we're going to use it to make that a 0. So we just have to do negative row 2 plus row 3. Okay, negative row 2 plus row 3. Negative times a negative, positive, plus 10 is 14. 5 plus 9 is 14. And so we made it a 1, made zeros. We made it a 1, made zeros. Now we make that a 1 by doing 1 over 14 row 3. And that's row echelon form, where we see that z equals 1, and then we're going to go y minus 4, z equals negative 5, and z is 1. y is -1. And then we're going to use this x minus y minus z equals 7. X minus y minus z equals 7. Y is -1. Z is 1. So that's going to be, and we can see that the solution is 7, -1, 1. Okay, let's just do one more. And you try this one. You're going to get to the end and it'll look a little different, but go ahead and practice getting to the end, and then we'll see how to deal with what happens there. So pause the video and try that one. And we almost have what we want here, and it's easy just to multiply by -1. Multiply row 1 by -1. And then we want to use this to make these 0. So we'll go row, we're going to go -4 times 1 plus 4. -4 row 1 plus row 2. We're going to go -3 row 1 plus row 3. -3 row 1 plus row 3. Alright, -4 row 1 plus 4, 0. -4 would be 12 minus 9. -4 is 40. 40 minus 34, 6. And -4 times -8, 32. Minus 17, 15. We're going to have -3 times 1 plus 3. -3 times -3 is 9, plus 5, 14. -3 is 30, minus 2, 28. -3 times -8, 24, plus 46 is 70. And we want to make that a 1. So 1/3 row 2. One-third times 3, 1/3 times 2, 1/3 times 5 gives us that. No changes here. And we now want to use that to make that a 0. So we have to multiply by -14 plus 14. -14 row 2 plus row 3. And we're going to go -14 times 0 plus 0. -14 times 1 plus 14 is 0. -14 times 2 is -28 plus 28. Negative 14 times 5, negative 70 plus 70, 0. So that's the, it looks different than before, and here's how we deal with it. When you get a row of zeros, you have to say let z equal a, and then we just solve everything based on a. There are infinite solutions, and we then do y plus 2z, and z is a. So now we can say y equals negative 2a plus 5. Here we have x minus 3y minus 10z equals negative 8. Z is a, y is negative 2a plus 5. Add 4a and add 15, and we get 4a plus 7. So then we write the solution like this: x, 4a plus 7, y, negative 2a plus 5, z is a. Alright, and we'll stop there.